Welcome to graphs of some of our basic functions. For this, you will need to be able to connect the rule for the graph with its graph itself. So let's start with our first lot. So the first one is a graph of our square roots. So the square root of negative numbers is not possible, and this turns out to be a sideways parabola. So when it's a positive square root, that's the top half of the parabola, and if it was a negative in front of the square root, that would be the bottom half of the parabola. So that's our graph as it looks. So you can see that it's the top half of the sideways parabola with values of 0, 0, and obviously if we go along to 4, the square root of 4 is 2, the square root of 9 is 3, etc. for that. So that's the first one that you need to know. The second one is graphs of odd powers. So we're talking, powers of 3, 5, 7, and they all look exactly how a cubic is. So you can see it sort of snakes through the 0, 0. It's just that the higher the power, the steeper the graph becomes, because when you get powers to the 2 to the power of 5, that's a lot steeper than 2 to the power of 3 for its value. Next graph is the graph of even powers. So that's powers of 2, 4, 6, etc. And you can see that all the even powers look like parabolas. And once again, the higher the power, the steeper the actual graph. So 2 to the power of 4 is a lot higher as a point than 2 to the power of 2. So when we sketch polynomials that are in factored form and have the different powers, the first thing is we find the zeros, which are the x-intercepts. So that's when we let y equal 0 and we solve for x. And then we find the y-intercept, which is where we let x equal to 0 and solve that. And that finds us our y value, or our y-intercept. So for that curve, x squared outside of x minus 1, outside of x plus 2 all cubed, we find the zeros when y equals 0. So for the x plus 2 to the power of 3, we let x plus 2 equal 0 and you get x equals minus 2. And because it's an odd power, therefore at minus 2, it will snake through as an odd power does. You'll notice that x squared, when x squared, the x equals 0, that's an even power, so therefore it's going to bounce off at x equals 0. And the x minus 1 is just a normal line that passes through at x equals 1. And if you sub in x equals 0 in there, you get y-intercept at x equals 0. So the question's always, how do we know where that graph actually starts? Well, our intercepts, as you can see, so our zeros are minus 2, so x equals minus 2, x equals 0, and x equals 1. So one recommendation is to sub in a value that's higher than the furthest 0, which is x equals 1, just sub in the next value that's higher than that. Just sub in x equals 2. And if you sub that in, you get a positive answer. So that means when x is 2, it starts above the x-axis. And then we can come down through the x equals 1. We come up and we have a parabola type at x equals 0, so it bounces off. And then we have an x equals minus 2, it snakes through. Where they turn, so between minus 2 and 0, that will be part of a future topic where we'll actually use calculus to find the turning points. So we can see there's one somewhere between minus 2 and 0, and there's one somewhere between 0 and 1. And they're not halfway. They can be at any sort of interval there, depending on how the graph is. But for the purpose of this video and these exercises, we will just turn it somewhere between minus 2 and 0. So the final graphs for this video are graphs of circles and semicircles. So circles are always in the form of x squared plus y squared equals r squared. And semicircles, if you rearrange the circle formula to get y by itself, the upper part of the semicircle is y equals the positive square root of r squared minus x squared, and the lower half of the semicircle is y equals the negative square root of r squared minus x squared. So a quick look at this. So we did x squared plus y squared equals 9. So r squared equals 9, so that makes the radius 3, square root of 9 is 3, and we just end up with a circle that passes through 3 on the minus 3 and 3 on the x-axis, and minus 3 and 3 on the y-axis. And if we look at the upper and lower for that same circle, so the upper would be the positive square root of 9 minus x squared, so that's the red, and the lower is the negative of the square root of 9 minus x squared. Thank you.